Tonight we are working on a 2017 Mitsubishi Mirage. It's one that I've never looked at or worked on before, and it's actually going to be my first three-cylinder engine as far as checking things and diagnosing drivability problem. But the main reason why it was brought to me was for check engine light, misfire, and rough running. And they've attempted to do plugs and coils or whatnot. I did scan this off camera, so I wanted to just get you a quick shot of what the trouble code is in the engine computer. And we've got two codes here. A P0016, which basically cam crank correlation, and then the 0300 misfire detected. I'm not going to worry about the 300 as of right now, because if we're not synced properly, we're going to run poorly. So kind of maybe straightforward, possibly timing issue. This does have an intake cam phaser, so that's going to come into play. As far as what has failed or is failing, whether it's chain or a phaser or a solenoid, we don't know. That's what we're going to try to find out. I can get you a quick shot of what it sounds like before doing any type of testing. It's kind of surging right now. It's just running very kind of poorly. One thing I did notice, it kind of what they call, I guess, kind of dieseling. When you shut it off, it still sort of runs a little bit. But yeah, that's the symptom, the running symptom, along with the trouble codes. And now we will dive in and see what's causing the problem. Okay, I'm actually all set up here to start testing. I am in cylinder number 1 with the transducer. Then I've got the crank signal, cam signal, and then I am in the intake manifold as well. I've got all three injectors unplugged. I'm going to start by just doing a crank, no start, looking at obviously the pressures in the cylinder. Curious to see what the intake manifold pulses look like. And then as far as cam crank, being that we're just going to be cranking with the chain set to where it's at, I want to see that either the cam stays steadily put, or it'll kind of I want to see if it fluctuates while cranking, which it should not. Basically, I'm looking to see if there's a phaser, like a locking pin issue, like a broken locking pin, and if it's allowing the cam to walk slightly or a little bit while it shouldn't, because it should be in its lock state, and we're just cranking with the chain spinning the motor in its installed position. After that, we'll take a look with it running and so on and so forth. Okay, we'll crank no start it and see. Okay, so before I showed you the capture of the one I just did during cranking, I quickly off camera did do a relative compression, just to get a quick kind of idea or reference, or just to see what this 3-cylinder is gonna look like. Make sure there's no crazy things popping up before continuing any further, even though we know it looks like there's some sort of timing issue going on. So right off the bat, just in this far away view, nothing really stands out. We just have our our buildup of compression. I do have intake also and ignition on one. So this is going to be the starter current draw for the cylinders. And just to get you a view, blown up view, here's cylinder 1. And the firing order is actually the same as a 4-cylinder minus the 4. So it's 1, 3, 2, 1. Yeah. So this is 1, 3, 2, back to 1. And there are your intake pulls, 3 of them. So pretty straightforward, nothing crazy. Just thought I'd throw that in there. Now this here is the one that I just took while cranking. And so the breakdown of the channels, again, green is going to be the intake while cranking. Blue is in cylinder pressure in cylinder 1. And then I have in the yellow gold is the cam, and in the red is the crank signal. Right now, not too interested in the intake and in cylinder. The main thing that I want to try to see is if the what the cam signal is looking like throughout the whole cranking time from its position, to see if it stays put, and then if so, then we can go about looking to see if it's a performance issue while running. What I'll do is blow this up here in the beginning portion, and again we are wanting to look at the relationship or reference between the two. So one thing that I want you to look at, let's see, is basically where these teeth line up in reference to the gaps per se, and then this is the identifiable one for the cam. It's a big one with a small one, and we are in the beginning portion of the cranking event. And so these teeth, or gaps I'll call them, are to the right of the crank sensor gaps. And if you look right here at this point, this one is now in the gap. That's the one with the double tooth one. So I'll go, actually from cycle to cycle you can tell. This one here is not in the gap yet, that portion there, and this very next cycle it is. So between here and here, the cam signal has moved in relation to the crank reference point that we've used. And so then the further we go, and if you look at these also, they're not in the gap. And this one now is starting to be in a gap portion of the crank sensor. And so this one's now in the gap. That's one we saw. This one has now moved even further this way, and this one's fully in there. Again, now the small one's starting to line up right at that ending point of the gap of the crank sensor. and then I believe this is where it stays at this point, where this small tooth kind of just enters that ending point of the crank, and that's where it's shifted to. And just to get you a reference, we bring up, and here we are about halfway point, and this is cranking. So, and then if we go all the way to the end, as I said, I believe that's where it stays shifted at. So now we are pretty much at the end, and that double tooth is staying in that spot. So we don't know, because we've never seen or worked on one of these. We don't have a known good cam crank. All we can go with is based on how the system is set up, and based on experience working with other either similar systems or more complicated ones. This one's pretty straightforward. It's an inline engine with single variable cam timing, which is on the intake, and it does have a solenoid, which then gets activated by the computer. So we know that at cranking, with most gears, they're supposed to be in their return locked position, and with no high oil pressure and no basically command of duty cycle. Your intake cam, or the cam with the phaser, should stay put. So this one we know should stay put while cranking. But this is why I wanted to do this, just because of the nature of the code. I wanted to see or try to differentiate if it's a chain issue, a phaser issue, or what's going on. But being that we can see something just even at cranking, you know, you can just wonder what it's going to do idling and running, and so on and so forth. So looks like there's going to be probably a loss of cam control. So I wanted to get back to the beginning portion and kind of take note to try to, because let me bring you up on this. This is something that I want to try to also make sure it wasn't coming into play and then we start chasing our tail. If you see the intake pattern, how it dips down and then kind of comes up and stabilizes, if you've done enough of them, some manufacturers almost sort of change their idle speed, or cranking speed cranking speed when doing a compression test basically, and you crank it for an extended time. The GM is one that comes to mind. If you crank it for a while, you'll hear even a change in tone and speed when you crank it for a while. So this one looks to do something similar. It must just play with the throttle body blade for a little bit of the angle, and it changes. It does change your pressure and speed. So what I wanted to do was to make sure, since we are seeing the shift somewhere, seeing if we can see where that shift starts, if it correlates somewhere within that area. So again, we'll zoom in and start going to the point where we see that first cycle of this double tooth move in the advanced portion into the gap area, and we'll put a marker there. So there to there, it starts moving, and there it's fully moved. So we'll put a marker there. Put one. We've got one here, and I'll put one on the very next one also, just to get an idea of where we're at up top. So sure enough, we are close to the point, not exactly there. We are towards the probably beginning area of where that's going to start to change over. So what I wanted to do to not chase my tail of seeing this shift, possibly due to RPM change and shift, I took a second capture. And that second capture is this guy here. The only thing I simply did different was hold the gas pedal down. When you do this, you take away your resistance, and then you can't see your intake pulls. When I say resistance, is the intake pulling resistance, so you're like more vacuum because you're fighting against the blade. Once you open the blade, there's no resistance, so your pressures are higher, less vacuum, and you can tell during the whole cranking that the vacuum was not there because we've got the blade open, so pressure stayed high, so there's no drop. This was one way where I can tell that the RPM stayed steady throughout the whole cranking event, because the throttle is not going to change the angle, the blade's not going to change the angle, and we're going to be more consistent. And I want to see if we still have a change in shift in the cam signal. So here we are in the beginning portion of that. So we're starting again towards the right of the gap with the teeth, and we'll just keep scrolling over. And right there, same thing. This one, it's right at that point, and the very next one, we've already shifted over again towards the left. It's advancing. So again, uncontrolled movement of the intake cam on its own while just cranking at a consistent RPM. There's still movement. At this point, I know and have verified that the shift occurs on its own. There is no reason to believe that RPM change caused that, and I am pretty sure that is not supposed to happen, and that's part of the problem why we're seeing some timing codes, because we cannot have control, or we are not able to control the intake if it's moving on its own. Okay, now after doing all the cranking testing, I've got the 2 injectors plugged in for cylinders 2 and 3. I'm going to go ahead and let it run and idle. I do for the moment have the oil control valve unplugged. I want to let it idle, cold idle with no VTC interaction. So scope's running. Let's crank it, run it, see what it looks like. Okay. I was having a hard time. I had to give it some gas there. Okay, so this is that capture we just did of cranking it and trying to get it to run. We had a rough time getting it running. It would start, stall, start, stall, start, and finally got it to stabilize by giving it a little bit of throttle. And then we just let it idle for a little bit. Again, this is with the oil control valve unplugged. I want you to look at where we're at. So I quickly went over here to the right to where it's sort of stable, and I'm gonna show you At this point, the cam has shifted to the point where we've been used to seeing it, when that small tooth is right at the ending portion of that gap of the crank. And I want you to look at the in-cylinder pressure. And here we have our TDC, so 720. And I want you to look at, we've got the expansion area, your exhaust, intake, and then compression. I want you to pay attention to this in the exhaust area, this down ramp down towards intake. We'll take a measurement, and I'll just do it from that peak point there. But from the 360 on over, we are, looks like 47, 48 degrees before 360. So that was here on the what is basically sort of stabilized portion. Intake cam fully moved to the point we know where it moves to. And I want to bring up now an area here before the cam moves. Alright, so look at this. The difference on the exhaust portion where we have an intake pull is way past 360. Before it was happening 47, 48 degrees before 360, somewhere in this region. But here, before the cam has fully moved all the way where that small tooth is in that gap area, or at the end of that gap area, we have a very delayed, retarded intake valve opening event, as we clearly see it there. If we want a measurement, it is 26, 27 degrees after the 360 mark. Now, just for idea or reference, I wanted to point out or look at the exhaust valve opening area, if we can get a general idea. So here to here, about 22 is what we're getting. And then here, in the point where the cam has shifted and we have advanced intake event, the time on the exhaust valve opening is still in the same region. This right here clearly shows us a good picture of what's going on as to why it's running the way it's running, and the trouble codes and all that. Exhaust is not moving. Intake clearly moves from beginning of cranking with no oil pressure to fully cranked with more oil pressure during cranking, or when at idle with, again, yet more oil pressure. The thing about it is, cranking or running, the intake cam moves to the same exact spot. Okay, so now what I want to do after looking at the running in-cylinder and cam crank, I want to let it run, and I want to provide power to the solenoid myself and watch it on the scope and see what kind of results that gives us, if any, if we're able to control the phaser. As for right now, it looks like it's moving on its own. So I want to see what applying power to the solenoid, which is supposed to control the phaser, what's going to happen, what it's going to look like, what it's going to do to the signals, so on and so forth. So I'm setting up to do that, and we'll take a look. Now, before I even go ahead and get started, most of the time when I do this and apply the 12 volts, just like any solenoid pretty much, you'll hear an audible click, and I'm just not hearing it. I don't know if it's moving or not, so I decided to get an amp clamp and see if I see anything, even though I can't hear anything. First, I'll try to get you a shot of maybe you trying to hear. And I can't hear anything, and so I will show you what it does look like. So I want to get that amp clamp just to see also if I'm getting any amperage. So I'm definitely getting something on the screen as far as amperage goes, but I'm not audibly hearing it. So I think I'm still going to go forward trying to see what it does because I'm getting some amperage. I'll go ahead and attempt to idle it, apply voltage, see if anything happens. I might want to pull that solenoid out and take a look at it just because I'm not audibly hearing something, but let me run this test first. Okay, and here's the capture of the idle with me manually activating the oil control valve. You can see that with the green channel is going to be the amperage, so we can be able to identify when I did activate it in case we didn't see anything different. So it's a good reference point. So we'll go down to what we know again. That is the cam signals. That is the cam and crank. Which it's already at its shifted point, as we can tell there, and we'll scroll over till we start to see the green channel come up, which we do there. And at that point, that double tooth area looks how it always does. And after we have amperage, the double point still in the same area and has not moved. Again, with it being held, still no shift. It's still in that point that we have become familiar to where it travels to. Again, still having it on, voltage applied, no movement, different than from the idle. Now with the drop in voltage or amperage, there's double tooth in that area, and again double tooth in that area. So no control with the solenoid being activated and not activated. The cam has already shifted and it is not moving, even though we are attempting to move it again. So at this point, I initially was thinking about a phaser issue, especially once we saw that the cam was moving on its own during cranking when I knew it shouldn't move. And then still sort of was thinking that during the idle situation where it moved the same. But now, with the two things I'm seeing now with the oil control valve, number one, not hearing an audible click, and number two, when applying voltage, to see no movement and or no control of the phaser. I am beginning to wonder if the oil control solenoid valve is stuck in a certain position to where it's allowing oil flow through once we get enough pressure built up into a certain cavity, basically I guess to the advanced cavity of the phaser, when it shouldn't, and that is why we are seeing that, or it's stuck to where it bleeds off and they can't lock it back, so on and so forth. So I'm beginning to just, I think, narrow everything down now to possibly, quote unquote, simply just an oil control solenoid valve. Again, it said if it cannot control the oil flow passages and pathways, and it's being sent to the wrong chamber or to a chamber at a time when it shouldn't, then it's gonna move the cam. So I think the next step is to simply remove the oil control valve, look at it externally, see if it's jammed up, and kind of go from there. Well, this is just needless to say, this is where things went south. I went to remove the oil control valve, which is held in by a simple 10mm bolt, and then it's supposed to slide out of that bore. And once I did, the electrical portion had broken off. And that's what I was left with. So now comes the fun task of, well, not only are we not going to be able to simply verify the valve being stuck, since we have completely demolished it, but now I was left with the task of trying to figure out how to get that out without damaging the cylinder head. That's a picture of what I was left with compared to the new one from the dealer. So that's finally what I was able to use to get it removed. I hammered in an extractor, and then with the socket just went counterclockwise till it finally spun free. And once it was spinning, I just was able to pull it out. Okay, so I got the new solenoid back in. I cleaned up as much as I could, the best way I could. Just before starting or doing any type of testing, I want to see if this solenoid would make a clicking noise, and just for comparison reasons. Let's see. So this one, just right off the bat, is actually clicking like I normally would expect the solenoids to click. And so this is definitely a good sign, obviously. Now I'm going to go ahead and crank and no start that unplugged, obviously, and I'm going to do, I believe, just the cam and crank and get a measurement. So again, we'll look at the same area and portions. And we'll start to scroll over, and we'll pay attention as to, again, the double tooth one. So where this drop down lands right about there. There it is again. Again. And again, so there's 4 cycles, and then I am good and comfortable with that as far as knowing that a shift in the cam is not being caused by a phaser. And after that, I wanted to get a shot of it while running at idle. Okay, so now I'm gonna let it run and idle, and I'm gonna activate the solenoid and see what that looks like. And so here is that shot of it at idle with it unplugged and with me activating at these 2 points. It definitely looks a whole lot different because if you can see there, we have high pressures going on in cylinder. So we are definitely advancing the intake cam when we are commanding it advanced. To get you a shot of that in detail, we are now zoomed in, and here is that double tooth of the cam, again same point, and here's where we get some turn on of the solenoid, and in that turn on probably not enough oil flow has gone through yet because we are similarly in the same spot. There's that gap, but right away here at this point we do have a movement, a travel, and more of a travel, and again, yet again, more of a travel there. And between that one and that one, looks like that's where it stopped. As you can see there. And I believe, yep, that is, and that is the point of where the, when faulted, that's where that cam tooth was falling in relation to the crank. So I guess that is its full advanced lock point there that we were seeing it shift to on its own. And then we'll continue, as we know we are gonna turn off here, so we'll keep in mind where that is. And right away it's already shifting with the loss of oil pressure to the phaser. It's already going in the retarded position. Again, more travel to the right, and there is, it's probably, I think it's, yeah, final point there to there. You can see that that's its starting point. So we do have now a well operating oil control valve that is able to control the intake cam clearly, and when cranking and or unplugged at idle, the cam stays put. So we know for sure 100% this is not going to be a phaser issue. It's not a timing chain issue. It is basically, quote unquote, simply just a oil control valve that was stuck, and looks like it was stuck in its advanced position. And once enough oil flow got through those passages and into the chamber of the phaser, it would move it to the advanced point. And obviously if you don't want it to be advanced, it's not going to idle right or run right, and it's going to cause all havoc. Alright guys, so that's it for this one. I guess just in closing, I hope that you guys enjoyed this one. It wasn't terribly too difficult. It was just a matter of taking a look at all the information that was gathered, trying to decipher or figure out what was going on. I enjoyed it. I hope you did. Hope you took something from it. And for now, that's all. We'll get this back to the customer and move on to the next one.